0 viewers. Maybe. Okay, well, I'll figure it out.
Okay. And I need to do a screen share.
Oh, is she? We're gonna go ahead and start. No, this is what, thank you, Tom.
Okay. You want to talk in the headset in case anybody is there?
Sure, I guess. How does?
Oh, the other way. Oh, I have it where it is on the left. We're going to go ahead and get started.
I can't hear now, but like that. All right. Okay, everybody, could you please take a seat? Let's give Tom Latta, our musician, a round of applause. Thank you. I think all the songs you played tonight are on a CD that you released. Okay, so if anybody wants a CD, see Tom. And this evening's program is going to be given by Carolyn Omperon, who is a new climate reality leader. She went to Brazil, of all places, to get this training to give an updated version of the Al Gore presentation that was in An Inconvenient Truth, if you remember that film. Carolyn is also going to be our new Sierra Club chair beginning in 2015. Couple of things I want to remind you of. Sierra Club calendars are now on sale, and they are available back there on the table. The second thing is, if you are a bag band supporter, I don't know, some of you may not know that the club has proposed a bag ban ordinance to the city council, and we are looking for petition signers. So those petitions are back on the table. If you would like to support that initiative, we'd appreciate your signature. And now Carolyn.
Thank you very much, Jen. Okay, and if you wonder why we're wearing this headset, it's because we're also streaming over the internet using Google Hangout. We're trying this again because some of you may not realize that since we have a couple hundred Sierra Club members in town, but we actually have 800 additional Sierra Club members in mid-Missouri. And so they don't get the chance very often to participate in our meetings. So we thought we'd start trying to offer them by Google Hangout and see if anybody shows up. So tonight I'm going to try and do that. I realized it made it a little bit more complicated. So in hindsight, might not have been the best thing to do my first time giving this presentation. So I also wanted to introduce tonight, we have Dr. Johann Brun with us, who is a retired research professor from the University of Missouri. Dr. Brun is also a climate reality leader. He got trained 2 years ago, and so he's here to help me in case I get in trouble with any of these slides. And you guys have questions that perhaps I can't answer. So I do want to let you know, if you have questions, please do interrupt me. And Jan is going to watch on the internet to see if anybody online asks a question. So as Jan said, the Climate Reality Project is Al Gore's international organization. He formed it with the goal of enabling people around the world to be able to share the reality, as it's called, of our climate crisis, our climate situation. And the idea is to be able to have people be able to help educate and raise awareness of the challenges we face with climate and what solutions we have in order to address them. And so a couple times a year, they hold a training which is attended by people from all over the world. The one in Brazil had people from 35 countries, and they trained 700 new climate reality leaders, some of whom are even children. There's a school in Mexico that brings like 20 or 30 children to every training, and to elementary school, junior high type kids. so that they are learning, and can start sharing this from the early age on, because it may be that generation that really is the one that ends up having to solve this. Um, so anyway, so I've learned the presentation, but I have to tell you, Mr. Gore has 500 slides in his presentation. So I know, the library closes at 9 p.m. So, so we don't have time to go through 900 slides. So I have gone through them and picked out ones that I thought you might be interested in. I do want to mention that both Johan and I are available to give presentations, and those presentations can be to different groups. So if you have a church group or a business group, like a social civic organization, anything like that, we'd be happy to talk to. And the presentation can be customized to allow people to make it, what people are going to be interested in. Are they more interested in the basic science? Are they more interested in solutions? Are they more interested in the current status of the climate? Those type of things. So the presentation can be customized, and either one of us is available to help with that. So let me go ahead and start this. Okay, so I decided to skip the basic science of why greenhouse gases are warming the atmosphere. I thought a lot of you are probably already familiar with that. So we're just going to jump right in and talk about some of the problems that are resulting from the warming. And then I will also talk about the status of some of the solutions. So yeah, fix that if it got crooked again. So one of the things that I do want to mention is that, and Al Gore said you should always mention this, is that sometimes the first part of the presentation can be quite depressing. So please stick around for the second half of the presentation, where we talk about all the reasons to have hope that we, as a global community, can solve the climate crisis and see all the great progress that's being made around the world in driving the transition to clean energy and other activities that are underway. So the first thing I want to talk about is, where do greenhouse gases come from? Well, most of you are probably familiar with the fact they come from burning fossil fuels, and that is a great focus of the presentation tonight. But they also come from other sources that you may not be as familiar with, such as the burning of forests, or the land use, like agriculture or industrial processes. And then, one that was new to me recently when I took a class on climate science at MU was the thawing of the permafrost. That is a big one that's looming on our horizon, and I'll talk more about that in the presentation. So, so these are just some of the sources, and so we'll be going through some of those in more depth. So the big one that is responsible for the majority of the problems that we have right now is the carbon emissions from fossil fuels. As you can see from this slide, that back in like 1850, we had very low carbon emissions in the atmosphere. But as we started the Industrial Revolution over time, and as the Industrial Revolution picked up steam and spread around the world, and more countries began using fossil fuels, the emissions grew and grew to the point where we are today. So as the scientists have been studying for years. They knew that we were starting to see warming in the atmosphere. And so they've been studying for years what the cause was. And this isn't just like a new phenomena. They've been studying it for 30, 40 years now, about what are the causes. And so you can see here that there is a distinct linkage between the CO2 concentrations, and this starts back in 0 AD and comes up to current time. And this is, you sometimes hear people refer to the hockey stick. So this is the hockey stick that we're talking about on the slide. And then you can see also that there is temperature variability despite the fact that CO2 remained constant. That is because there are forces in nature that do cause the temperature to vary. Volcanic eruptions, the orbit of the Earth around the sun, solar flares. So there's different things like that that can cause climate temperature variations. But the scientists have done the due diligence and they have eliminated all of those natural causes. And so that's why they have come to the conclusion that it's man-made emissions from greenhouse gases that are producing the global warming that we're experiencing. And so you can see here, as we had this hockey stick effect of CO2 concentrations increasing, we also have the increase in global average temperature. So this is just another slide that shows, sometimes you hear people talk about the parts per million of CO2 in the atmosphere. And there's even an organization called 350.org, which stands for 350 parts per million, which was the desirable concentration of CO2 in the atmosphere to keep us at the climate that we're used to. However, we've passed that now, and the world is now at 400 parts per million of CO2 in the atmosphere since 2014. And then the projections, if we don't do anything to change our ways or mitigate our use of greenhouse or our emissions of greenhouse gases, is that over 40 years, over 40 years, our concentration of greenhouse gases is going to put us at 600 parts per million in the atmosphere. So you can imagine how hot it's going to get if we actually allow our climate to get to that point. And you know, there's a few people, or several of us in the room, potentially have the capability of still being alive in 40 years when this happens. So I see definitely a few young people that are going to be here. So a lot of people say that some of the climate deniers say that, or the people that maybe they believe in global warming, but they don't believe man is causing it. They say that humans can't possibly impact the atmosphere, that we're too small and insignificant compared to the planet to be able to impact what's going on with the atmosphere and the climate. But the problem is that they're not remembering that there's now over 7 billion people in the world, and many of those people are driving cars and, you know, using, their homes are heated with electricity from coal or gas. And so Al had his team do an analysis, something that might help people understand the amount of energy that has been trapped in the atmosphere because of man-made global warming pollution. And so they came up with, and this is a conservative estimate, of that the pollution that we have produced that's now trapped in our atmosphere is equivalent to the exploding of 400,000 Hiroshima atomic bombs per day, 365 days per year. So if we blew up 400,000 atomic bombs every day for a year, that's how much energy we have polluted our atmosphere with that's causing this global warming. So if you think about it in those terms, it's a little easier, not a lot, but a little easier to think about how that kind of energy, that kind of pollution could be causing an impact on a global scale. So the next few slides are a little bit complicated. They're the most complicated ones we'll talk about, but I think they illustrate a really important point. So I'm going to attempt to explain them. So in school, most of us probably studied the bell curve. And so what this slide is showing us is a baseline. This is the initial baseline, this green line, from the 30 years from 1951 to 1980. I think many of us were alive, we've all been alive at that point. And what we have here is the red represents warmer than average days, and the green represents cooler than average days, and the white are the average days. And so what we're going to look at is how this changes over time since 1980. So now we'll look at the next decade, which is 1981 to 1991, and we see a shift from the base. We see that the number of red days, or warmer than average days, has increased, and we have a new category over here with those outlier days, which are extremely hot days. So more extremely hot days have shown up on the radar screen for the first time. Now, if we advance again from 1991 to 2001, again, you can see that we have an increase in the number of warmer than average days and even more extremely hot days. 2001 to 2011. This was a really hot period. And so you can see, oops, sometimes loses my mouse. You can see that here, this red period now of extremely hot days, which wasn't even on the charts during the baseline period, is now equal to the cooler than average days. And then when we talk about these extreme temperature events, they used to only cover 0.1% of the Earth, but now they cover 10% of the Earth. So all of these phenomena that we'll talk about tonight are global. They're not, so just because it's cold here in the United States, it doesn't mean we're not having a record hot year around the globe. And so that's a really important point to understand. And one of the points of this presentation is to help you have the facts so that when you talk to your relatives or your neighbors, you might be able to raise some questions for people to think about if they haven't started thinking about climate change. So that's why I want to try and explain it in a way that you can remember it. And if you have any questions, please ask. So having seen that set of slides there with the progression of the extremely hot days, you can probably understand that 12 of the hottest years on record have been since 1998. So you can see there, and I'm sure you remember some of them. I know I certainly remember 2012. That was when we had the drought, and oh, it was so hot here. And then 13 of the hottest years on record have occurred in this century. So the 21st century, since we turned over to the 2000s. 2013 was the 37th consecutive year with a global temperature above the average from the 20th century. And October 2014, so just last month, was the 356th consecutive month with a global temperature above the 20th century average. So you can see here, we're talking trends. So even though every now and then we may have a month in the United States that's colder than normal, that the trend is that our global temperatures are rising. And this is just another way to look at it, global temperatures by decades. Because sometimes people will take a specific year and they will try and say, oh, there's been a pause in global warming. The scientists are all wrong. Well, if you look at this and you look at it by decades, you can see that there isn't a pause in global warming, that the trend is just continuing to go up. So even though there may be anomalies in certain years, we are on a trend of warming temperatures around the globe. So now we're going to talk about where does that heat go? So some of it is in the atmosphere. But one of the reasons why warming hasn't happened faster than it has is because 90% of the extra heat that comes from man-made global warming pollution goes into the ocean. And so our oceans have been buffering us from the impact that we might have otherwise felt from the global warming pollution that we've been putting in the atmosphere. So the ocean absorbs this heat energy, and what it's doing is absorbing the CO2. And this has multiple negative effects on the ocean. In addition to just raising the temperature of the water, it actually is increasing ocean acidification because of that carbon dioxide and the reaction of it when it's in the water. And so ocean acidification has a significant impact on the food chain in the ocean system. It impacts the plankton, which then, the small fish eat the plankton, and even some of the great big fish eat plankton. And then, those fish, there's not as many of them. And so you have the whole impact on the ocean food chain. So this basically shows the progression of global ocean heat content. They measure this at a depth, the kind of the surface depth of the ocean. It says 0 to 2,000 meters here. That's 1.25 miles for us Americans who didn't convert to the metric system. So you can see here that we've had significant growth in the temperature of the ocean since 1970. And this is true a lot of the growth in the problem with global warming with the carbon dioxide emissions has been happening since the Industrial Revolution. But some things got significantly worse in the 1970, 1980, 2000 time period. And this is one of them. So what happens when the ocean warms? So one of the bad things that happens when the ocean warms is that it transfers that energy to a storm. And so when a storm goes across the ocean, it's picking up moisture from the ocean, and it's picking up heat energy from the ocean. So this shows the path of Typhoon Haiyan, which hit the Philippines a year ago. Oops, back up. And you can see here that this is these red areas, the dark pink, the red areas, show the areas where the water was much warmer than normal. So an anomaly, it was warmer than normal. And so when Typhoon Haiyan went across this area of the ocean as it approached landfall in the Philippines, the water was 3 degrees Celsius warmer than normal. So that's significant, 3 degrees Celsius. And so that's one of the reasons why Typhoon Haiyan was such a powerful storm. And in fact, it was one of the most powerful storms, that they've ever had in that part of the world. This just shows the aerial view of the typhoon, so you can see really how large it is, and it picks up moisture and energy from the ocean, and that's why they always talk about how when it makes landfall, the wind speeds are gonna reduce, and it's because it's no longer picking up that energy from the ocean; it's dispersing it when it hits land. So as long as it's over this warm water, it's going to keep picking up energy. Okay, so now let's look at another map of surface temperature anomalies. So this is from October 2012, and some of you may remember what October 2012 was. It was Superstorm Sandy. And so you can see here again, the reddish colors represent the temperatures compared to the 1981-2010 average. So again, high temperatures compared to a base period of a number of years ago. And up here off the coast of New York and New Jersey, we can see that there was a lot of this red. And so in this case, when Superstorm Sandy was coming across this part of the Atlantic Ocean before it made landfall, it was actually 5 degrees Celsius, so even warmer than the water was for Typhoon Haiyan. That was 5 degrees Celsius warmer when Superstorm Sandy came across the ocean and created this megastorm. And so really this is what where Sandy turned into a superstorm. And you can see here from this satellite photo that how huge Sandy really was. It was 1,000 miles wide. And so it really picked up a lot of energy and a lot of moisture when it came across those warm ocean waters. And so the reason the ocean is so warm is because when we pollute the atmosphere with CO2, the ocean absorbs some of that CO2 and some of that energy, and then that's causing the ocean to warm. So just to talk, so we've already obviously been talking about the linkage between the climate crisis and the increased frequency and severity of extreme weather events. So we'll talk about that a little bit more, but obviously those were two extreme weather events that occurred. So this is a quote from a scientist with the U.S. National Center for Atmospheric Research. And this is a bit of a departure from some things that we had been hearing. Global warming is contributing to an increased incidence of extreme weather because the environment in which all storms form has changed from human activities. For a while, the scientists, you probably heard on the news, and I saw it on the internet, you can't attribute any one specific extreme weather event to global warming. But now the scientists are saying, well, really, because the entire climate system has changed, we can attribute these really extreme superstorms to global warming. So why do we get another effect from the global warming is that not only does the temperature increase in the oceans, but we get more water in the sky in the form of water vapor. And so this photo is showing how it's got image from aggregated from satellite data, and it's showing the water vapor as it's moving around the world. So the climate system as a whole is it includes the water vapor in the atmosphere as well as the prevailing trade winds. And so you can see here how the water vapor is moving around. And so as temperatures in the oceans increase, that allows more moisture to evaporate into the sky or the atmosphere. So we need to, before we go on to the next step, we need to think back to the water cycle, the hydrological cycle it's called, where, and I think we studied this in elementary school, at least I think I did, where the water evaporates from the ocean or the land, and then once you get enough of it in the atmosphere and the conditions are right, it falls down back to the earth or with precipitation. And then that water eventually ends up in creeks and rivers and streams and makes its way back to the ocean. So that cycle is very important for understanding the next points. The fact that warmer air holds more water vapor. So we have that cycle continuing just as it always has, but now the air is warmer. So when the water evaporates from either the ocean or the land, the air can hold more of it than it used to. And I've had at least 2 climate deniers try and tell me that the reason we have global warming is because there's more water vapor in the atmosphere. And it's true, there is more water vapor in the atmosphere, but it doesn't stick around very long. It falls back down to earth and then it gets sucked up again, and it's always going through this cycle. It's the CO2 or the CO2 equivalent greenhouse gases that are causing the global warming, not water vapor in the atmosphere. So the important thing to understand in terms of this impact on us long term is with each additional 1 degree Celsius of temperature, the atmosphere's capacity to hold water vapor increases by 7%. So based upon the temperature rise that we've already experienced, there's 4% more water vapor over the oceans today than there was only 30 years ago, because we have already experienced about 0.7 degrees Celsius temperature rise. And so this is one of the effects that we see. The temperature's higher, the oceans are warmer, and so the air is holding more water. Well, so what's the impact of that? So when the air is holding more water, when it's time for it to rain, we get downpours, and the downpours are bigger. And so we had one of those recently in Colombia. I think we got 5 inches in a day. It didn't beat the record, but it tied the record. So, you know, that's something that we've seen locally. That wasn't enough to cause major flooding, but some places in the United States and in many places around the world, they've had amazing downpours with like 2 feet of rain that have caused significant flooding. And you'll remember Boulder, Colorado, I think it was, I don't know if it was a year or 2 ago now, but they had the significant downpour that caused all the roads to wash out. So this is a chart that shows the increase in heavy precipitation days. So again, this is related to temperature, because the temperature causes the water vapor in the atmosphere to increase. That causes the precipitation to come down in very heavy downpours. So the rate of rain is much higher than it has been in the past. And so you can see here in the period of time where we've had significant temperature increase, we've also had significant increase worldwide in heavy precipitation days. And so this is true on all continents. The large downpours cause bigger and more frequent floods. And if we weren't streaming this on the internet, I could show you a bunch of pictures. So if we have another time where we do a presentation where we're not using the internet, then there's a lot of photos that they have included in this presentation, but because of copyright rules, I wasn't able to include them tonight because we're streaming on the internet. But amazing pictures of these floods around the world. from these heavy downpours. So, but one example here that I do have is, and I'm sure you might remember this from the news because it caused the United Kingdom to actually start taking climate change more seriously. In the winter of 2013 through August of 2014, it was the wettest on record for the United Kingdom. And so again, if you look at this table here, the dark blue represents rain that's 225% above average for this time period. So you can see why they had rain and floods. They had parts of England or the Great Britain that were underwater for 8 weeks. And, you know, so this was enormous flooding in England and was, you know, really a first for them to have this kind of rain. So 225% above average rainfall. And this is another picture of the storm that just shows again how when the water is warm in the ocean, it allows these megastorms to be created. This storm covers basically the entirety. This is England over here, and here's Ireland, and you really can't see the landmass. The storm covers the entire country of Great Britain. So as these global temperatures continue to increase, so will the intensity of the water cycle. So this is just one of those processes that just keeps going on, and the more the temperatures go up, the more the water cycle will intensify, and the more water vapor that will be stored in the atmosphere, which means even more downpours around the world. So the interesting thing, though, is at the same time, sorry, this thing just keeps slipping. At the same time that we have the water cycle conditions creating these downpours around the world, it simultaneously can create droughts in other places or even in the same place in some situations. So, so I want to talk through this a little bit, so about why this is the case. So first, as we've talked about, evaporation from the ocean into the atmosphere increases more as the temperature goes up. And then as the air gets warmer, it holds more of the water vapor instead of releasing it more frequently as rain. So 3, heavy downpours get even heavier, causing worse flooding. And then 4, and this is one of the problems that we're having in the western United States, the snowpacks melt earlier in the year, leading to more spring flooding, but less water in the heat of summer. So if the snowpack, because normally you want the snowpack to melt gradually throughout the year in the places that get their water from snowpacks, like California, and instead it's melting very early in the year, and there's not there then for the summer flooding. So this is then the next steps are what's causing the longer and deeper droughts. So there are longer intervals then in drought-stricken areas between the downpours, making droughts even worse. And I think you can probably remember in our drought here, it was the case. It didn't rain for very long periods of time. And so this is one aspect of this phenomena of these heavy downpours, is that then it doesn't rain for a real long period of time. And so that makes the droughts worse. And then because it's hot, more water evaporates from the soil more quickly, and then that also makes the drought deeper and longer still. And so we talked about how the water is evaporating from the ocean and pulls more moisture and pulls moisture out of the ocean, but it also the heat causes the extra heat causes the water to evaporate from the soil very quickly. Most of the water in the soil is kind of close to the surface of the soil, and so when there's added heat, it allows that also to pull the water out of the soil. And so really we're seeing a lot of places around the world in drought conditions. Since I was in Brazil, it was interesting that over 140 cities in Brazil right now, or in February, were rationing water. And that is still continuing. Sao Paulo, one of their major cities, has significant water rationing. And part of it is because not only because of global warming, but the other part is because of deforestation of the Amazon, and they have broken or damaged their own water cycle right there in Brazil with deforestation of the Amazon. And one of the points that I wanted to make with this is, and of course we could use these, get similar numbers for the United States for the 2012 drought or for the California drought, but these numbers were in the presentation, that the drought cost Brazil $4.3 billion in agricultural losses just in one quarter. So one of the points that's important to think about when we think about taking action on climate change is that, because people say, oh, it's too expensive, we can't switch to a clean energy society. But we are already spending a lot of money because of the loss of the damage to agricultural products, the damage to infrastructure from flooding, the damages like Superstorm Sandy. We are paying in many ways for this already. And so the time is now to start investing in the transformation to a clean energy society so that we don't keep having these increased costs from the damage from climate change. Another drought that is happening this year is in Central America. And I thought this was kind of interesting. They have the yellow represents the abnormal dryness and the brown represents the drought. And so I was wondering how much, because we've had the situation with all the people from Latin America coming to the United States with the women and the young children. And I was wondering, how much is this contributing, because it's causing unrest in the countries. They have food insecurity. And they have had, in Guatemala, for example, they've lost 80% of their corn crop was damaged or destroyed. And so you realize when you lose 80% of a staple product, because and this is the part of the country where they make their tortillas out of corn, not flour. When they use a staple of their food supply like that, then it causes significant problems in the society. Another area of drought that has created a situation that is of global concern now is Syria. Syria had a significant drought from 2006 to 2010, and it turned 60% of Syria's fertile land into desert. Actual desert. It went from being cropland and cattle pastures to desert. And so this displaced like 1.5 million farmers and herders into the city. By 2010, the drought had killed 80% of the country's cattle. So if you think about this, is all leading up to the beginning of the Civil War. So these 1.5 million farmers and herders are now living in overcrowded cities. They have no means of income, and or they're living in refugee camps. And this was actually a public statement, but it didn't actually get exposed and have public play until WikiLeaks released a bunch of United States State Department memos. But the United States Embassy in Syria sent a memo to our State Department here in the US that the Syrian Minister of Agriculture stated publicly that the economic and social fallout from the drought was beyond the capacity of their country to deal with. To have this many people displaced and out of work and having no income and no food from the drought. And so what this leads us to is an understanding of how global warming and climate change are contributing to the global instability situation. And the United States Department of Defense has actually issued a report that says that they consider the future threats caused by global warming to be significant. And as it says here, this is mission reality, not a political debate. They understand that the force to cause people around the world to have food insecurity, to have water insecurity, and to have their livelihoods displaced, and then it's going to create more Syrias where we may be asked to come in and help with the situation, either help with the refugees or help with the political unrest. And so our military is in the future. And of course, I'm sure all of you have heard in the news about the drought in California. This is from May, this image, where by that time 100% of the state was in severe drought with 25% in exceptional drought. And just to kind of help you picture what this really means for California, This is one of the largest reservoirs in California. It's a picture taken in July 2011, Folsom Lake, California. And then now this is a picture taken in January 2014. So you can see how serious the situation in California really is. And not only are the reservoirs empty, but the snowpack was not there either. So they had no snowpack to melt and feed the reservoirs from the mountains. So the other point that needs to be made about global warming, and particularly the Western United States, but this also applies to a lot of other countries as well, Africa in particular, that when the temperature goes up, so do the number of fires. And it's not just the number of fires, but it's the intensity of the fire and the amount of acreage that they burn. So this is another result of global warming, that now, and I'm sure you've probably heard on the news, the fire season used to last a certain number of months each year, but now in the Western United States, they have year-round fire season. It never stops. And so they attribute this to global warming. And the other problem with forest fires is not just the amount of money that it costs to fight the fire, which is significant. It almost bankrupted California one year because they had to fight so many fires in one year. It's not just the amount of money to fight the fires or the destruction that the fire may cause to people's homes or businesses, but it's also the fact that when those fires burn, they're burning trees and vegetation that store carbon. And they're also then releasing more carbon into the atmosphere. So it's becoming one of those cycles. The warmer it gets, the more fires we have. The more fires we have, the more carbon from the trees that are burned gets released into the atmosphere. Okay, so now we're going to change tracks just a little bit. And although we've touched on some of these points, and talk a little bit about the global systems that are vulnerable to climate disruptions. And we've talked a little bit about how this can lead to political or social instability. We'll talk a little more about this. In the interest of time, there's actually four. There's food supply, there's water, there's global health, and there's infrastructure. In the interest of time, though, I'm only going to talk about food supply and water tonight. So if you want to know about global health and infrastructure, you have to, invite me back. Okay, so food supply. So we talked a little bit about this. So we all know that droughts significantly impact the amount of, crops that can be produced. We've seen, we live in the Midwest, we've seen the dead plants in the field. But there's another new thing that the researchers are finding out, and that they've just recently been researching what is the sensitivity to crops to heat. So if it gets warmer, not a drought, but it's just hotter, what does that do to the crops? And so they have found out that the crops are very sensitive to heat and how fast that heat is increasing. So current research indicates that for every day during the growing season, the temperature goes above 84 degrees Fahrenheit, maize or corn, which we grow a lot of here in the Midwest, yields decline by 0.7%. So 84 degrees Fahrenheit, well, you guys know we're having a lot of more days that are over 84 degrees Fahrenheit. So that's already impacting crop yields, even when we have corn yields, I should say, even when we have enough rain. And by the end of the century, U.S. corn yields are expected to fall by 1/3 from heat stress alone, not just from drought, but from heat stress on the plants as they're trying to grow. Another study was done by Kansas State University. Kansas is the center of wheat production. And so they did a study on wheat. The last one was on corn. This one's on wheat. And so they found for every 1.8 degrees Fahrenheit in projected mean temperature was found increase. So if you increase the temperature by 1.8 degrees Fahrenheit, that the decrease in wheat yield is nearly 21%. So again, we don't have to have a drought. We just have to have increased temperatures to have our production from our agriculture systems go down. And so this is very important to the Midwest and Missouri. And they've also studied to find out that not just yields are impacted, but the actual nutrition quantity of the food is impacted. So the nutrition levels in rice, wheat, and soybeans, when there's more CO2 in the atmosphere, it's actually reducing the percentage, the amount of nutrition in the food. So even if we were getting the same amount of food, it would be less nutritious for us. So what about Missouri? What are the projections? So we've seen how heat can impact our crop yields. And so Missouri is a big agricultural state, as is the rest of the Midwest. And so what are the projections for Missouri? And these numbers are from the National Climate Assessment that was done by our government. So if carbon pollution would continue at its current rate, meaning that, we take a do nothing approach, as so many people want to do, and temperatures continue to rise as the scientists project, the Midwest could warm as much as 4.9 degrees Fahrenheit by mid-century and as much as 8.5 degrees Fahrenheit by the 2080s. So you can tell that there would be some significant impacts, not only on us as humans, but on the crop yields as well. And Missouri is expected to have the number of days per year above 90 degrees Fahrenheit increase by 20 or more days by 2041. And so, when you really think about it, 2041's not that far away. And so we'll be looking at a really significant number of days over 95 degrees. And if you think back to the slide on the corn was affected over 84 degrees. So it's a significant impact on the lifeblood, really, of a lot of the people here in the Midwest. And then what's the other impact of all of these issues with agriculture? We have 2 examples of food price spikes already, actually probably 3 if we count beef prices, which is happening right now, which came from the drought of 2012, and also the fact that the feed for cattle is still very high. So we have a food price spike in the United States with beef. But the 2 that are here on this slide, the first one around 2010 was caused by Russia taking their wheat off the global market because they had the hottest year ever since 1500. So 1500, hundreds of years ago, Russia had their hottest year ever, and it produced a drought, it produced forest fires, and they had significant crop loss. And so in order to feed their own people, they stopped exporting to the rest of the world. And Russia is a major wheat exporter, just like the United States is. And so this caused a major price spike in food prices. And then the 2012 spike, which is this one, that was caused by the fact that 50% of the United States was in drought. And again, the United States is a major food exporter. So all of these things affect world food prices. And when you're living in a country where, you spend a majority of your income on food, that can make a big difference. So we can solve this, but we have to get going before it gets a lot worse. And so what are the scientists predicting for drought intensification? And unfortunately, a lot of these drought problems that they're forecasting are in some of the most populated areas of the world. So in order to avoid what we're about to see, we have to, as a global community, sharply reduce global warming pollution. So let's start with drought conditions in 2000 to 2009. So not a really bad period yet. And so you have to pay attention to the scale down here and see that the bad colors in terms of drought are white and these different shades of purple, and pink is not quite so bad. But when it starts getting into purple and white, that's not good. And so we'll look at then, now we'll jump forward to 2030. So this is 2030 to 2039, and you can see that the United States has got some pink and some purple right there in the heart of the growing belt the grain belt of the United States. And then also we see problems here in the Middle East and in Europe. And of course, Latin America and the northern part of South America. So moving on, 2060 to 2069, now we start to see white showing up, and white is very bad. White is very dry. And so this little bubble here in the Midwest that was pink before is now, or in the grain belt, has now expanded, and it's also gotten worse. And look at Europe. All of this area, which is, like where civilization has existed, since the Middle Ages and earlier, is in severe stages of drought. And this is a very highly populated area. And it gets worse. This is 2090 to 2099. We can see that all of this area now has turned white over here in Europe, in the Middle East. And then, of course, the areas have expanded in the United States, Latin America. The drought intensifies in South America, and also includes, not as bad, but includes Southern Africa. Okay, so now let's talk about water more specifically. Obviously, that was somewhat about water. So where does our water use come from? So on a global basis, 11% of water is used for domestic uses around the home, what we drink, what we wash with, all those type of things. 19% is industrial, and the rest of it is agricultural. And this is one of the challenges that California is having right now, because they've had to tell the agriculture that they can't take the water anymore from the surface water. They can't have the reservoir water anymore. And so that's why they're drilling wells and things like that, because they are been shut off from the other sources of water, because they obviously want to keep their livelihood alive. So as temperatures rise, so does water use across all of this spectrum. People need more, crops need more, energy needs more, livestock needs more, industry needs more. All of these things need more water as temperature rises. So, the wars in the next number of years are probably going to be over water. We've been fighting, unfortunately, over fossil fuels, but now in the future, we're probably going to be fighting over water. And the other thing that causes the needs for water to rise is the population. So in developing countries, which a lot of them are still having significant population growth, the demand for water is expected to grow like 50% just in the next decade. In developed countries, it's supposed to grow about 18%. So just from our population growth and our economic development, things like that. So this is a graph that shows countries that are overpumping their aquifers. And so as you can see, the United States, unfortunately, is on here. And whoops, let me go back. Several bad things happen when you overpump your aquifers. And right now, all of these things are happening in California. Your wells run dry. Before it runs dry, you usually have deteriorating water quality because you start pumping up sand and dirt and things like that. You get land subsidence because that water was kind of holding up the earth. And so when you pump it all out, there's room then for the land to sink. And so this is happening in California too. They're having their infrastructure is starting to, in some cases, crumble because the support for it is going away. So there's lots of problems with overpumping aquifers. And so this is definitely not something that we want to do. We want to cut our water usage, and not have our aquifers depleted. And these are the underground aquifers. Okay, so now we're going to shift gears, and we're going to talk about sea ice. Sea ice, for me, was probably the first thing that I heard about in the respect of global warming over the last few years. People started talking about the polar bears and the sea ice, and that was all what they talked about with global warming initially. And as you can see here, sea ice has been on a downward trend. This chart is from 1979 to 2012. And it's measuring the sea ice in September, which would be like the end of the summer period. And you can see in 2012, that there was a new record low, and certainly the trend line is down. And so why is sea ice important? Because in the Arctic, the sea ice actually floats. So it's not contributing to sea level rise when it melts. But why is it important otherwise? Well, it's important because it's an indicator for us of the health of our planet, in the sense that our way of life, our climate system, was based on the fact that there was a certain amount of sea ice every year, and it was a certain temperature in the Arctic. And so the Arctic is warming faster than anywhere else on the planet. So it's like the canary in the coal mine, if you guys remember that expression, where the canary would die first if there was bad gas in the coal mine. Well, this is our indicator that bad things are going to happen to the rest of us, because it's happening first in the Arctic. So that's why they watch the sea ice so closely, because it's the indicator of things to come for the rest of the planet. Additionally, and so since many of us are lovers of wildlife in this room, of course, the impact on the wildlife is significant, with the polar bears and the walruses and the seals not having the sea ice, which they call home, and where they need to be able to have the sea ice to hunt and live their lives as they have been. So this is another depiction of the sea ice from September 1984, and the expanse of how much sea ice that there was before significant warming started to occur. And now if we switch to this slide, this is September 2012. And so you can see that the sea ice is significantly smaller, and why the scientists are concerned. And this is all unfortunately happening faster in some instances than they had originally forecast. Now, another greenhouse gas that you may not hear, so we hear a lot about carbon dioxide or CO2. Another greenhouse gas is methane. Methane is actually 30 times more potent as a greenhouse gas than CO2 is. It doesn't have quite as long of life in the atmosphere. CO2 stays in the atmosphere for over 100 years. And so that's one reason why it's so important for the collective community to start taking action now, because what we've already put up there is going to stay there for 100 years. Well, methane doesn't last as long, but it's 30 times more potent when it doesn't last as long in the atmosphere, I should say, but it's 30 times more potent when it gets up there. And so sometimes you hear the scientists talk about tipping points, certain problems that global warming creates for us that makes it, that may be irreversible, that are going to start this cycle where one thing starts to feed on another, and then things just get worse and worse and start to multiply. Well, unfortunately, methane from the permafrost is one of those tipping points. In Alaska, there's the permafrost and the tundra, and in that there are these pools that store methane. And as long as they're frozen, the methane is trapped, it's stored, it's secured, it's not going to get in the atmosphere. But when it starts to thaw, then that methane starts to release into the atmosphere. And there's methane in the tundra and the permafrost. There's also methane stored deep in the ocean. So just to let you know, there's multiple sources of this problem. So as the permafrost thaws, they're forecasting that Alaska may release 250,000 metric tons of methane into the atmosphere every year. And so this is really significant. So we need to change things quickly to stop this from happening, because it's estimated that in only another like 10 to 12 years, Alaska's tundra could turn into a carbon source, meaning it's releasing methane, instead of a carbon sink, meaning it's storing methane. So today, the tundra is storing methane. There is some melting. It's already starting to release some, but it's not large yet. But in 10 to 12 years, they're forecasting, if we don't make changes quickly, that it is going to become a significant problem. And then this starts to feed on itself, because all that methane in the atmosphere increases global warming even more, which increases the heat that's going to melt that tundra even more. And so we have this vicious cycle that that's why they call it a tipping point. Another thing that's happening, and these do impact sea level, is glaciers. There's a lot of glaciers around the world, and they are melting, and they call it retreating. And this does impact sea level rise because this is ice that's on land. Anytime ice that's on land melts and the water makes its way to the ocean, that's what's going to cause sea level rise. The other problem with melting glaciers is that a lot of these glaciers, as they go through in the past, as they went through their annual cycle of building up in the winter and then thawing a little bit in the spring and summer, they produced water for people in many places around the world. So lots of people around the world are dependent upon glaciers for their fresh water source. So when we lose glaciers, ultimately those people are going to lose their water source because it's no longer going through that cycle of building up in the winter and then having a little bit of melting in the spring and summer. Unfortunately, now they're melting a lot. So here we have the Columbia Glacier in Alaska, and if you look at this area here in the middle, this picture is from 1984, and you can see that the glacier is very large. And now this is a picture from 2012 where this glacier has disappeared from this whole area. So again, like the rest of the Arctic, Alaska is feeling a lot of the effects of, what time is it? 8, thank you. Is feeling a lot of the effects of the global warming first. And then I had to include this one because, of course, John Muir is one of our, favorite people in the Sierra Club. And so this is a picture of a glacier named after him in Alaska. This is a picture from 1880. And so you can see how really large this glacier is, how deep the ice is, just a really significant glacier. And so now we'll look at that glacier in a more recent photo. This is from 2005. It's no longer a glacier, it's a big old lake. Good news is there's still water there, but it's not a glacier anymore. Okay, so we were talking about the Arctic. So now let's switch to the other end of the world and talk about the Antarctic. And the Antarctic is different than the Arctic because in the north, the Arctic in the north, the ice floats. So it's already in the ocean, and when it melts, it's not necessarily going to drive sea level rise. But in the Antarctic and in Greenland, it's different. That ice is all on land. So when it melts, it's adding fresh water into the oceans, and that's what will drive sea level rise. So between 2010 and 2013, the Antarctic ice sheet lost ice at the rate of 160 billion metric tons per year. That's twice as much as during the prior survey, which was 2005 to 2010. So there's always been some loss of ice. There's some melting, some flow under the ice to the ocean, but the rate is rapidly accelerating. And so that's what this picture shows. So you can see here that the ice sheet velocity measured in meters per year, the blue to the pink to the red, is the area where it's moving very fast. So the ice is flowing now from the land into the sea. And so we can see that Antarctica is having a significant change in the rate of flow of the water into the ocean. Look at all that water flowing. So, and you may remember that earlier this year, there was an announcement of a scientist report that the West Antarctic ice sheet is starting to melt, or is melting, and that it's considered to be irreversible. Well, this quote from the NASA Jet Propulsion Laboratory scientist is that controlling climate warming may ultimately make a difference not only in how fast the West Antarctic ice will melt to the sea, but also whether other parts of Antarctica will take their turn. So right now, it is considered irreversible, that it is going to melt. But if we can slow down the rate of climate change, or hopefully eventually stop it, then we can control how fast that melts and how fast sea level rises. And if we can do it fast enough to stop, further climate or global warming, then we can stop the rest of Antarctica from melting. So what do experts expect on sea level rise? So if we take really strong actions, which there's certainly been a lot of good news about that lately with the United States and China agreement leading up to Paris. So if we take really strong mitigation efforts, which means reducing our greenhouse gas emissions, they expect that sea level rise would be 40 to 60 centimeters by the end of the century. However, with unmitigated warming, they expect that to be double. So it shows that we do have the opportunity to make changes and to, deal with and prevent the worst impacts of climate change still. Even though we've ignored this problem for too long, we still have opportunities to make changes and have an impact. So we know we have to change. Yes, we do. So some changes have been underway for a number of years now. So I know many of you probably remember all the hubbub about, the rainforest a number of years ago. We must save the rainforest. And I was interested when I went to Brazil because I thought, well, I haven't really heard people talk about saving the rainforest that much anymore. What's going on with the rainforest? So if you look at 1990 to 2005, there was several nations that topped the list of nations that were cutting down their forest, Brazil being one of them, as was Australia and other parts of Africa and Indonesia. And so this was a significant problem because not only were they cutting down forests, which hold and store carbon, but they were also cutting down tropical forests, which are rainforests, which help participate in that water cycle. This is just a photo from, unfortunately, 2014, this year, of continual land clearing fires that are happening in Brazil. So even though they've made significant progress to reduce deforestation, it is still happening. A lot of the deforestation that's going on right now, though, is illegal. And so they're making significant steps to try and deal with it. And actually, we in the United States can help with that. For example, Lumber Liquidators was just cited for purchasing illegal lumber. And so, some of our laws actually can help if they are enforced. The United Nations, recognizing the United Nations Conference on Climate Change, recognizing that deforestation is a major problem, has a special program focused on reducing deforestation. And so it is working in all of these places. And so there have been several success stories, Costa Rica being one of them, where you can see they've cut their deforestation rate almost to zero. And one of the good things that they've done is they have figured out how to use their forests for tourism. I know many of you have probably seen all the ads to go to Costa Rica. Brazil was another one of those states that was really bad with deforestation, cutting down the rainforest for farming and for cattle ranching. They have made significant progress with reducing it. Unfortunately, they also have had a little uptick, and so that's something that they talked about, the officials that were at the meeting talked about, and they're very concerned about, and so they're trying to address that. But really, what we need is for deforestation to really get even though they've saved an amazing amount of the rainforest, something like the equivalent of 15 million soccer fields have been saved. We need to save even more. So globally, a lot of progress has been made, and the rate of deforestation has dropped by 20% in the period of 2000 to 2010. So we've talked a lot about different negative impacts that are coming from the cost of carbon: political instability, drought, famine, sea level rise, water scarcity, storm damage, floods and mudslides. I skipped infectious diseases today, but that is one of the problems: wildfires, melting glaciers, ecosystem loss, species extinction. Another thing we haven't talked about, but a significant number of species will go extinct because of climate change and infrastructure loss, our way of life, and much, much more. So what do we need to do in order to deal with all these issues that we have that are resulting from all this carbon pollution in the atmosphere? Well, what we need to do is put a price on carbon in the markets, because most economists say it is the most effective and the fastest way to drive change in our global system is to put a price on carbon, because then people start making decisions based upon the new economics of the situation. Just like coal is more expensive now because of all the regulations in the United States on cleaning the pollutants before they spew out of the stacks. So not too many new coal plants get built. So that's what you want to do, is change the dynamics of the economy and put a price on carbon. And I'll put a plug in. I know we have several people in the room, myself included, who are members of Citizens Climate Lobby. And that is another nonprofit organization that's focused on working and advocating with our Congress to get a national price on carbon passed in the United States. And what's the other thing that we need to do? Having just passed an election, we need to put a price on denial in politics. And this is definitely something that is not happening yet, but we need it to happen. And even back to 2012, I remember signing petitions to try and get in any of the presidential debates, to get one of the moderators to ask a question about climate change. And they didn't. There were so many presidential debates, and there was not a single question on global warming or climate change in any of those debates, even though we, as Americans and as citizens of the world, face a significant threat. So this is another thing that we have to do. So I'll skip through this part pretty quickly because I think a lot of you are familiar with it. You've probably heard quoted a lot that 97% of climate scientists agree that global warming is real and that it is being caused by human-produced greenhouse gases. Well, a new research study has been done that looked at climate papers, peer-reviewed climate papers, which means they've been reviewed by other scientists, and those scientists who are also experts agree that the researcher did a good job. And so we looked at the peer-reviewed climate papers from November of 2012 until December 2013, so about a year. In that period, 9,136 authors agree that climate change is happening and it's primarily caused by human activity. So it's no longer 97%, it's now up to 99.99%. One paper did not. So one person wanted to be a contrarian. Additionally, it isn't just a United States thing. It's not a United States conspiracy. Some people like to say it's a conspiracy, it's a hoax. Well, it's not. Every major national academy of science in every major country in the world confirms anthropogenic global warming, which means that's a big word to mean that it's caused by humans, anthropogenic. So we're causing it. All the major national academies of science agree. And so it would be a little hard to get all of these scientists around the world to agree on something that if they really didn't believe it, to actually produce some type of conspiracy. And how many national academies reject the science of anthropogenic global warming? None. So they all agree. And here's what they said. Unfortunately, they said this in 2009, and it really hasn't sunk in yet with a lot of countries. But they said the need for urgent action to address climate change now is indisputable. So we need to have been taking action for the last several years, but the sooner we start, the better. And so we have a lot of solutions at hand, and so that's what we'll talk to next. So this is where the hope part of the presentation comes in case you're feeling a little depressed and sick to your stomach right now. This is where we start to, talk about how we can really make a difference. So green energy progress. How do the projections compare with reality? So projections looking at the past and saying where were we going to be with green energy now. And so 2000, the projection was that worldwide wind capacity would reach 30 gigawatts by 2010. The reality is that by 2013, that goal was exceeded by a factor of 10 times. So even though the bad stuff is happening a little faster than we anticipated, the good stuff is actually happening a lot faster than people forecast. Here's another one. China, and everyone, of course, wants to blame the United States inaction on China. But China is actually doing a lot. They're a big country, so they obviously have a lot to do, but they are actually doing a lot. So the projection in 2000 was that China would install 2 gigawatts of wind by 2010. The reality is that China exceeded that goal by 22 times and may reach 75 times by 2020. China is installing a lot of wind energy and a lot of renewable energy. And what is the cost of onshore wind? So, there's windmills that are onshore, and then there's also some that are offshore. Well, we're looking here at the cost of onshore wind. And so this is megawatts deployed on the bottom of the graph here. And so you can see that the significant trend line is down on the cost of wind. And so the good thing that we'll see here as we go through this is that the trend line is down on the cost of all of these different renewable energy sources. Yes, Molly? Well, let's see. In 2000, they were projected to install 2 gigawatts by 2010, and they have exceeded that by 22 times. So I'll let you do the math. And I could probably get you a more specific number, but I don't have one off the top of my head. So globally, wind could supply worldwide electricity consumption 40 times over. So we have the potential to get all the energy we need from a variety of renewable sources. And any one of them, if we built enough windmills, like in this case, if we built enough windmills, we have the potential to get all of our electricity consumption from wind. So now let's switch to solar. So in 2002, the projection was that the solar energy market would grow 1 gigawatt per year by 2010. That's really not very much, 1 gigawatt per year. And the reality is that that goal was exceeded by 17 times. And in 2013, it was exceeded by 39 times. And this year, it will be exceeded by as much as 55 times. So significant solar installations are happening around the world. So, and this is another way to look at that. So this is 1980 to 2013. You can see here it started taking off around 2000, 2004. And the price, of course, started coming down. And so we have significant solar installations ramping up. So the good news is we got a long way to go to completely get off of fossil fuels, but at least we're starting the ramp up to achieve the desired objective. And one of the things that Mr. Gore pointed out was that you have to. So some people say, well, we can't possibly do this fast enough to get where we need to be. And is there any precedent for another technology that has been adopted as quickly as we need to adopt clean energy technology around the world? And so that's the question. Is there any other example of technology that was adopted this quickly? So let's think about the cell phone. In 1980, AT&T commissioned a study to forecast cell phone use by the year 2000. So 20 years, 1980 to 2000. They projected less than 1 million users, 900,000 users in that 20-year time period. The actual figure was 109 million, 120 times higher. So why was it that cell phones could be adopted so quickly, not just in the United States, but in countries around the world? And there are 6.3 billion cell phone connections. So we went a long way over 900,000. So why were they wrong, but they were really wrong? The first reason is the costs dropped sharply as the quality improved dramatically. the purchasing decisions could be made by individuals instead of utilities, and developing countries that did not have these extensive landline networks like the United States had just said, the heck with landlines, we're just going to go with cell phones. And so they put up cell phone towers and their population got cell phones. So the cost dropped, quality improved, individuals could make the decision, and it leapfrogged old technology. Well, all of those conditions apply to solar. And, just to give an example, I'm getting solar on my house this coming Tuesday because I, as an individual, can make that choice. I don't have to depend on my utility company to do it. So the costs have dropped significantly on wind energy and solar photovoltaics, and the quality has improved in terms of the amount of energy that can be generated, and we can leapfrog the old technology. So let's look at just an example of the cost of those solar cells dropping over time. So in 1977, the cost per watt was over $76 a watt. In 2013, it was down to 74 cents a watt. So significant drop over time. And the new decisions and commitments coming out of China about their deal with the United States and what it's going to take for them to be able to achieve that deal means that they are going to be deploying even more solar and wind, which is going to drive the price down even further. Because as you guys all know, the more you produce, the lower the cost per item that is required. So solar grid parity, what does that mean? I actually had to look that up. What solar grid parity means is that the price of doing something a new way, like with solar, is equal to or less than what you might be paying today for your electricity. So when you achieve solar grid parity, that means it's just as cheap, if not cheaper, to go with the new thing as whatever the existing thing is. And so some countries have already achieved this. I actually don't know the mechanics of why they achieve it versus as other places. Maybe because of the support in their countries for solar. But you can see here through 2010 to 2014, these were the countries that were expected to have solar grid parity, meaning it's just as cheap. And this might be on the wholesale market, not individual consumers, but it's just as cheap for like a utility to use solar as it is for it to use coal. Yes? Yes. Yes, that is people's houses, yeah. But they did caution me that in this whole thing about from country to country, it could, be more reflective of wholesale prices than individual prices. And then this is showing projections for where we will have solar parity around the world. And so within 6 years, we expect 82% of the world's people will live in regions where electricity from solar is cheaper than the average price from other sources. So that would be really good news if in 6 years that could be true, and therefore we would be accelerating our transition to solar. And then it gets, continues out through 2024. And so we have another hockey stick, but it's a good hockey stick this time with world solar installations from 1980 to 2013 increasing significantly. And just as there's enough wind power to produce enough energy for the whole world based on our current electricity needs, there's actually enough solar energy that reaches the Earth every hour to meet the power needs of the entire world for a full year. So in 1 hour of sunlight, we get enough around the globe to meet our power needs for a full year. So it's just something that we just have to take advantage of. We have to convert. And then economically, things are starting to change. This is a statement from Barclays. We believe that solar plus storage could reconfigure the organization and regulation of the utility power business over the coming decade. I know that's something that Molly's always fighting is the utility business and their control over of so many things. And because of solar plus storage, meaning that you can go off grid, your business or your home, you could have solar, you can store so that you still have lights at night and you would be able to go off grid. And so that is going to dramatically potentially change the way our utility companies have to deal with us. Morgan Stanley, energy storage, when combined with solar power, could disrupt utilities in the US and Europe to the extent customers move to an off-grid approach. Additionally, there's a lot of corporate America is usually, not with us in the environmental movement, but they're actually starting to see the light in many ways on taking a more sustainable approach. And I'm sure this idea of using 100% renewable electricity is not only something that is good in terms of their relationships with their customers, but I'm sure it's also good for their bottom line, because once it's installed and you've got your payback, then your energy is essentially free. So these are a lot of the companies that are already using 100% renewable energy. Al Gore said he sits on the board for Apple, and he said Apple is about at 96, 98% now. So he can add them to the slide soon. Sounded like he was eager to be able to do that. This is an example of how when a country makes a commitment, good things can happen. So you can see that at the end of 2013, Chile had 11 megawatts of solar power, but by the end of 2014, they had installed 287 megawatts. So when a country wants to, this is, when the United States decided it was going to put a man on the moon, when we make a commitment to something and all get behind it, we can do it. That's what Chile has done, and that's what the United States could do. Latin America countries are also installing a lot of solar. And again, this is kind of like leapfrogging the old technology. They didn't have a lot of power plants and things like that. And as their economies develop, they do have a need for more power. So instead of using the old technology, they're using the new renewables technology. These are just all the examples of countries that are installing more than 50 gigawatts of solar in 2014. And then back to China again. So, of course, it's really important what China does, because China is the largest polluter of greenhouse gas emissions at this time in the world. And so people are always keeping an eye on that. And so here is the CEO of Suntech saying that they're sure that by 2016 or the latest 2017, the levelized cost of solar photovoltaic will be the same as coal-fired generation in China, because it's really important that China get off of coal. They are, recently have still been building coal plants, but because of their air pollution, as well as the need to cut greenhouse gas emissions, they're going to have to stop that. So you can see here that China is definitely getting behind solar. Their installations are capacity is up 161% just in 1 year from 2012 to 2013. And this is the US. And so we are definitely making progress as well. We'd all like for it to be faster, but at least it's going in the right direction. And this is an important point when you talk with climate deniers and other people that are, keep talking about coal mining jobs. Well, I sympathize with coal miners. Nobody wants to lose their job. It happens to people all the time in every industry, not just coal. I mean, people get laid off all the time, whether they work at a call center or, a manufacturing plant. But solar industry jobs now outnumber coal mining jobs in the United States. So the way to go is to create more jobs, is to speed this transition. And, me as an individual taxpayer, this is my opinion, not Al Gore's, I'm willing to subsidize all those coal miners to be trained to install windmills and solar panels. So that's my opinion. I have to always say that whenever I express an opinion, that it's mine, not Al Gore's, or the Climate Reality Project. So in 2010, renewable investments exceeded those in fossil energy for the first time. Yay. And so that trend continues. We're expecting the full year figures for 2014 to show a clear rebound in global investment in clean energy. That came from Bloomberg. And new investments in clean energy in the Asia Pacific region are increasing, just like they are in other parts of the world, China and the United States. And this is from the World Bank. Green bond issuances. Green bonds are for clean energy infrastructure development. And so you can see that there's been a significant increase in those in 2013 and 2014. And so who pays for clean energy and low carbon development? Because this is important, because if we have to just rely on the government, it may not happen fast enough. But as you can see here, 62% of the investment in clean energy and low carbon development is coming from private corporations. And so that is good news, because that means that we don't have to depend on slow plodding governments. We can, depend on the markets, which is another reason that we need a price on carbon, because you can see then that the markets can drive these kind of actions. And according to Citicorp, the age of renewables is beginning. They said that in March of this year. Warren Buffett, he announced in June that he was doubling his investment, his $15 billion investment in wind and solar energy. And okay, so now we're going to shift gears a little bit and look at which countries have carbon policies. Carbon policies being something like a price on carbon or a cap and trade program. So unfortunately, it's not very much of the map here at this point. It is just these green countries as of October. And so the big question marks there are like India, the United States, excuse me, not India. The United States is certainly a big question mark, and Brazil. We need both of those countries to implement a price on carbon. China is piloting a carbon program. So even though they are the biggest polluter at this point in time, they are taking significant steps, not only in renewable energy, but they're looking at a cap and trade system. And right now it's being piloted in 5 cities and 2 provinces. And this city, I'm not exactly sure how it's pronounced, I'll say Shenzhen. They are the first out of the gate with their program, and they're expecting their program to reduce their carbon emissions 21% in a very short period of time. So China has taken several steps. They have banned the new coal-fired power plants in Beijing, Shanghai, and Guangzhou. And that's really, because of the pollution. I'm sure you maybe have seen on the news how bad the pollution is. They, whenever they, did the Olympics, or they just had a big meeting of global leaders, they actually shut down industry for a few days to try and clear the air before other people come to town. China will ban all coal use in Beijing by 2020. And China announced, and this is brand new, this was yesterday, China announced yesterday that it will cap coal use by 2020. So this is really important, because China and the United States just announced their new deal on climate. And a lot of people were saying, well, it wasn't hard enough on China, that they weren't going to have to do anything for like 16 years. They could just go on business as usual, but they can't. And they know that. And so that's why they've announced that they'll be capping and will cap their coal use by 2020. And that's what we need them to do, because we really need them to have their emissions dropping before 2030. The other thing that's happening in China is that they have started a greenhouse gas emissions reporting program. So thousands of companies across China will be having to report their emissions. And that's important, because one of the issues in the global climate negotiations was that China didn't have any kind of measurement system or reporting program. And so even though they're this big polluter, you couldn't measure what they were doing, and they didn't want anybody else coming in to measure them, of course. Can't have that. And so they've started this program, which should be very helpful when it comes to the next round of climate negotiations. And this is a quote from their president, that green and sustainable development represents the trend of our times. This is all the countries that are involved in the EU emissions trading system, which is a lot of countries that are, some of the countries that are not even in the EU participate in their emissions trading system. And greenhouse gas emissions in the EU are down over 19% since 1990. The EU has actually been much more aggressive than the United States. And Europe has pledged by 2030 to cut its emissions by 40% and produce 27% of its energy from renewable sources. This was from their EU agreement this year that they have with each other, which is important because Europe has still been one of the largest greenhouse gas emitters just because it's a developed country. And last year, the top 20 utilities throughout Europe reported losing half of their value since 2008. And why is that? Because of all these problems that we've been talking about. And so, and this is why you may have heard there's 350.org has a big divestment campaign going where they're encouraging people to divest their portfolios of fossil fuel stocks. And one of the reasons is because of this. So I'm just going to go ahead and bring the whole thing up here. So this is the amount of carbon or CO2 that was burned between 1850 and 2010. And this little grayer circle in the middle has been burned since 2000 because we accelerated because of global development our burning of fossil fuels. So that this is a really big circle, even though it's only 10 years compared to the rest of the circle. And over here is the remaining proven fossil fuel reserves. So this is what the fossil fuel companies know about. They've already discovered it. They don't have to explore for it. They know that where it is and they know how to pump it or mine it out of the ground. This is the amount that we could actually burn as a global community if we want to keep global warming below 2 degrees Celsius, which 2 degrees Celsius is the goal that all the countries of the world have set for themselves through the UN national climate negotiations. And that's 2 degrees Celsius increase over the pre-industrial revolution period. So, and we've already gotten about 0.7 degrees Celsius warming. So, you know, we still have a ways to go to 2 degrees Celsius, but, you know, we've come too far, in my opinion. So this gray bubble here in the middle, where'd my mouse go, is all that we can burn. So that means that the companies that have all the rest of this purple on their balance sheet, it's conceivably not worth anything if the world wakes up and says, we can't let you burn that. We can't let you, you know, use that oil. We can't let you use that coal. We can't let you use that natural gas. You have to stop. And so, you know, those companies are greatly overvalued today based upon these fact that what they consider these assets are in their stock or in their balance sheet. So that's why you know, from your own personal self-interest, it might be a good idea to divest of fossil fuel companies, as well as the goal of 350.org, of course, is to make a point to the fossil fuel companies that they need to be investing in clean technologies and not, you know, sticking with the old fossil fuels. So North America has some carbon pricing initiatives, even though we do not have a national policy. We do have 9 states in the Northeast that have a cap and trade program that's spurring innovation and also creating a lot of green jobs. And then there's also a Western Climate Initiative that involves California and 4 Canadian provinces that are also working together to develop an emissions trading program. Okay, so President Obama, which I know I'm actually competing with him this evening. He was giving a program that started at 8 o'clock on his new immigration policy. But he announced a while back in 2013 that he was directing the Environmental Protection Agency to put an end to the dumping of carbon pollution into the atmosphere for both new and existing power plants. So these regulations, the development of them has been in progress for ever since then. And it's these regulations that have changed the economics of building a power plant in the United States in terms of a coal plant. So they basically have halted the construction of new coal plants in the United States. In 2012, only 1 new coal plant in the entire United States came online. And so this is a map, and I wanted to show it because the Sierra Club has a campaign called the Beyond Coal campaign, which has been in place for a number of years now. So if any of you want to get more involved in this, that's one of the campaigns that you can get involved in. We actually have full-time people on staff in Missouri that are working on the Beyond Coal campaign. And what they try and do is prevent new power plants using coal from being built. And so you can see on this map the little factories, all the closed 2002 to 2008, and then all the ones that were X'd out are ones that were stopped. And the action of environmentalists like Sierra Club and other groups have contributed to making sure that those coal plants never got built. And now since 2013, when the president announced the new EPA regulations on new and existing power plants, even though they're not finalized yet, that was enough to scare people into realizing that the situation was, the economics of building a coal plant had changed forever. So where are we with new energy generation in the United States? So we see here for the first half of 2014 that we have a large amount of solar, a large amount of wind, some biomass, some geothermal, some hydropower, and of course natural gas has a really large portion at this time because with the recent abundance of natural gas, the price has come down. And so a lot of utility companies are converting their coal-fired generators to natural gas because it's less expensive for them. So for the first half of 2014, 56% of new energy generation came from renewables. So we are making progress. It needs to be faster, but we're making progress. And this just gives you a look at electricity generation. We can see that coal is going down. Gas, as I mentioned, is going up because of the price drop from the abundance of gas, unfortunately, from fracking. And then renewables has increased the most. This is also true of Australia. They also, even though they have a lot of climate deniers in their government as well, it's very unlikely, as this person from Bluebird says, that new coal-fired power plants will be built in Australia because they are too expensive now compared to renewables. This is just a statement that Ontario has ordered, as of January, the closing of its last remaining coal-fired power plant. So that's an entire province in Canada. So, and a lot of these actions, either the cities around the world, including the United States, or the states are leading the way. And so even though sometimes the federal level governments haven't taken the actions they need to take, just as with the Northeast states forming their own cap and trade trading program, you know, states can do something and cities can do things even if the federal government is not. Cars, we're not going to spend a lot of time on cars, but cars emissions obviously contribute, if they're fossil fuel burning cars, contribute to greenhouse gases. And this is just to show that global passenger vehicle fuel economy is improving and is projected to continue to improve. And the United States, thanks to President Obama, is making significant progress on this. And it's not just passenger cars anymore, but it's also trucks as well. Battery costs are coming down, and so that's making electric and hybrid vehicles more cost efficient. And then the new technologies in energy storage are removing the cost barriers for solar adoption and will also reduce the cost of electric vehicles. So we'll all be able to hopefully think about an electric car for our next one if we don't have one already. And there are a lot of different electric cars now in production that we can choose from. And then utility scale storage, this is being able to store wind energy or solar energy for future use so that we don't have to have coal fire or gas fired plants as backup during peak periods. There's investment is significantly increasing globally for utility scale storage. Smart grids. Smart grids are something that you combine like computer technology with the electrical grid, and there's a lot of different ways that you can make the electric transmission smarter and therefore more efficient, and you have like less energy loss. And this can apply to the grid as a whole, or it can apply to the specific power meter at your residence that can tell you, for example, that, well, if you would wait an hour to run your vacuum cleaner, it's going to cost you less than if you run it right now. So by the end of 2013, China will have installed 250 smart meters covering 62% of households. And this gets into the energy efficiency, because we don't just have to convert, we need to actually use less energy as well. And that helps speed the whole process of reducing greenhouse gas emissions if we can actually use less energy while this transformation to clean energy is on the way. And so these smart meters help people use less energy and be more efficient about their energy use. So China will be covering 62% of their households, or have already. The United Kingdom plans to have all homes using smart meters by 2020. This is a drone video of the climate march in New York City, which just happened in September. I was fortunate to be able to be there, and went on a Sierra Club bus. And it was really exciting because 400,000 people came out. And I attended the march in Washington in February 2013, and there was only 40,000 people. So from February 2013 to September 2014, we went from 40,000 people to 400,000 people. And so that just shows the increase in awareness and the concern of the public. And that's really what we need. We need the public to want to change things. And through that, we will generate the political will that we need to change things, like having a price on carbon. And this wasn't just held in New York City either. When people learned that this big march was being planned in New York City, events were held all over the world. And I think the total attendance, based upon the reports that they received, was something like 625,000 people around the world attended these events. And the timing was right before the meeting of global leaders at a UN climate conference. And word is that it had an impact, that every leader mentioned it in their discussion, that there were these marches being held around the world, and that they realized that their people want changes. And so this picture is of Easter Island. And so this picture is to tell us that we have a choice. There were once people that lived on Easter Island. Apparently, they possibly made the wrong choice, because there are no people that live on Easter Island anymore. And so we, as a society, we have choices to make. So I'm almost done. We're to the point now of what can each of us do. So the first thing is speak up. So whether it's speaking up to a state representative, a state senator, a congressman, a U.S. senator, or whether it's speaking up to your neighbor or your friend who says, somehow the conversation comes up that they don't care about climate change, it's important to help people understand why they need to care, why they need to vote people out of office who deny climate change and won't take action. And so that's the first thing that we have to do, is speak up. So as it says here, don't let denial go unchallenged. This is when the conversation, now obviously you have to be practical, especially when you're talking to your friends and relatives, but you need to be able to talk to people and help them understand. Use social and traditional media to get the word out. Obviously, a lot of us do things on Facebook and Twitter. You can share your thoughts there. And you can also write letters to the editor. A good thing to do is if a TV station or a radio station does a program on climate change where they talk about what actions need to be taken and they're supportive of action needing to be taken, call them and say that you are glad they did that program. Because a lot of climate deniers, and as they're called now, people that spam or hate, they will call and jump all over the station for running a positive program about climate change. So it's important for those of us who believe that climate change is a problem and a crisis to also call and say, thanks for running that program. Really glad you did that. Really important information you shared. So deepen your commitment. And this means not only, having those conversations or contacting your elected representatives, but it's about the personal consumer choices that you make to reduce your own energy usage, and also consider the environmental impact of whatever you're buying, which is one reason why we are doing the initiative here to try and reduce the number of plastic bags consumed in Colombia, because we're trying to reduce environmental impact, and also that could have a impact on reducing greenhouse gas emissions. And I put this slide here, even though we're at the end. I put this slide here because one of the things that you can make a choice on is companies that are responsibly sourcing palm oil. Until I first saw one of Johan's presentations, I didn't know palm oil was the big problem that it is. But one of the big reasons that companies, or that like in Indonesia, for example, that forests were being cut down and cleared was to plant palm oil plantations, because all of these major multinational corporations wanted to buy palm oil for their products. And it's amazing. Palm oil is in everything from soap to, candy bars. And so there's been several consumer campaigns that have happened that have helped convince these companies like Unilever and Procter & Gamble. I participated in the Twitter campaign with Greenpeace against Procter & Gamble to try and convince them to change. And I was astounded. Greenpeace only ran that campaign for a few months before Procter & Gamble announced that they would change their ways and they would source their palm oil sustainably. So it can make a difference. So, it makes a difference too. Like a lot of people don't like Walmart and a lot of things that Walmart does. And so they say, well, I'm not going to shop at Walmart. Well, that's good, but even better is to tell Walmart why you're not shopping at Walmart. And so it's the same thing with these companies. If there's a company that's still sourcing their palm oil irresponsibly, then we need to tell them we're not going to use your product because you haven't made this commitment. And then don't give up. Changing laws is even more important than changing light bulbs. Changing light bulbs is very important, but changing laws is even more important, because that is where we're going to get the speed of transformation that we need to really make the changes that we need to stop these tipping points and these irreversible changes from taking place. And so tell our leaders that this matters to us, whether it's telling our city council people, or it's telling our, U.S. Congress, or, Barack Obama, or the Department of the Interior. We have to speak up and we have to say, this matters to me. I care about this. I vote on this. And as it says, let them know that if they vote the right way, that you will strongly support them. You will work for their reelection. If they vote the wrong way, then you're going to oppose them. So, Molly, do you know how Claire McCaskill voted on the Keystone Pipeline vote this week? Yeah, so, yeah. Yeah, even though she's, she's not a climate denier, but she still makes some wrong votes, and we need to let her know that. So this is one of my pictures from the Climate March. It's time to save the humans, because, all these years we've been saving the whales, saving the seals, saving the rhinoceros. It's time to save the humans, because the truth is the Earth will go on even if it gets really hot. The people may not be able to survive, and many of the animals won't be able to survive, but the Earth will. So when we talk about the climate crisis, it's really about saving the humans. Thank you. Anybody have any questions? Thank you. Thank you. Thank you. Okay, thank you. Did you notice if anyone was online? Oh, that's my husband.
So thank you very much. We probably are going to have to hurry up and clear out of here, since it's about 10 till or 8 till 9. So, yes, George, you have